All right. Hello, everyone. Welcome to this week's Rochester Xamarin user group. It is May 28th, 2020. Before we get started, I always like to thank our sponsors. The .NET Foundation covers the cost for our Meetup.com account, and my company, File on Q, provides us the GoToMeeting subscription for us to use that allows us to bring this online for anyone to attend in the world, which we regularly have people from all over the world showing up. And I forgot to hit the play button there. Oops. I always do technical difficulties when I present and start these meetings. But without further ado, we have Roy here. He is going to be talking to us about creating persistent augmented reality experiences in mobile apps. He is a Venezuelan software architect living in Uruguay. I said that wrong. I know I did. I'm so sorry. I'm the worst. He's been using .NET since its inception, loves Xamarin, loves mobile development, and he's here to talk to us about augmented reality. And I'm going to hand you a presenter, and I'm going to let you take it away. Make presenter. Yes. Yes, I see the screen.
Well, you have my LinkedIn and my Twitter is there, and will be on the end if you like. Cover all the basic concepts and most of the tools you have to use. So with any luck, it will help you to actually make your first app probably tomorrow or the weekend when you could try to do something with augmented reality. If you have done previously an augmented reality application, you might find this a bit boring. So I'm sorry, well, I need to cover that, this point anyway. I will be talking about the tools, about AR Core and AR Kit for each platform, because this is a Xamarin group. Obviously, I will be talking about augmented reality with Xamarin Forms. And with that, after we understand all the basic concepts to create this type of experience, I will proceed to talk about how we can create these persistent experiences that, by the way, are also multi-user, multi-device experiences. And that's great. Let's cover the whole scenario. And we talk again also about a service from Microsoft called Azure Special Anchors that help us build this kind of experiences, with some tips, how it works, how we can integrate special anchors with Xamarin Form. We close with what's next. So what's the next technology that is around the corner. One thing I would like to clarify, I'm not the kind of presenter that open Visual Studio and you will watch me writing some code like crazy, under 10 minutes, because I think it's very boring. Because watching me writing code will be boring. So what I try to do with this kind of event is talking about the hows and the whys and answer the question, what the hell? Try to understand the things behind the code. And so these are small details that they are not on the code, but you believe me, when you get to the code, you download the demo, you will understand. Okay, now I understand why Roger mentioned this, or why Roger was trying to do this kind. So you will see some code over here, some demos running. Actually, capture the video for the demos, but I won't open Visual Studio. You will have you can download later the code and try it on your spare time. But the idea is to cover all the basic of the theory, all the diagrams, and as I said, answer why or how. That's I think is really, really important. So before starting, what's augmented reality? This is to start with a concept, and it's really funny because if you look around on the web, on several sources, even Wikipedia on English and Wikipedia on Spanish, something that I did, you'll find different concepts. Everyone has his own opinion of what's augmented reality. It's funny when you try to go Wikipedia English and Spanish, and it's not a translation, it's just a completely set of different ideas. So I picked one place and one of another. I came with this concept a couple of times, I guess months ago. It's an interactive experience where real world elements are combined or presented with digital information or virtual elements through a technological device. That's more or less a technical speech. But the important is the goal. It tries to incorporate digital elements to the perception the user has about the real world. And the key word here is perception. I'm not talking about what the user sees. I'm not talking about the user perceives. For give you an example, why that is different is because you can have an audio only based augmented reality experience. For example, if you have this application on your device that is tracking your location, like almost all applications I'm trying to do now, and that application based on your location give you a speech or small speech message through your headphone that said you are in this area, or the weather is going to be raining in 30 minutes or something like that. That means that application through an audio is changing your perception of the world. It's changing how you perceive things. So that is considered to augmented reality. So the idea when I say this to a group of people is you can go beyond thinking that augmented reality is just something you can see. It's about something you can also hear. And it's a lot better actually if you take those aspects in consideration, the sound and what the user see, because it allows you to create a more complete augmented reality experience for your users. And also opens a lot of different scenarios that at the beginning you haven't considered, especially, for example, for people who has a poor sight, is a lot better thinking with something that has actually sound. Augmented reality mode is nothing new. Actually, it's been over a lot of years, but it got recently in the news by a success case. And it was like 2-3 years ago when this company, IKEA, released this app for iOS, and it was something revolutionary when it came, very successful when it came out because two things. First, it wasn't a game. It was the e-commerce app, the catalog app, with augmented reality functionality. And the second was the reach. It was available for all users. It was just a segment of them. And that was quite revolutionary at the moment. No one expected somebody to do that in this area. Everyone thought that augmented reality has something to do with gaming. And it became this huge success. They later ported the app to Android. And of course, with every great success, there was a lot of copycats. A lot of applications tried to do more or less the same. But it proved something. You can do augmented reality inside your application for mass consumption. And that's something to do with entertainment. It can be just, in this case, an app to place a new sofa or a table in your living room. Obviously, in terms of gaming, other companies decide to do a small game, quite successful, I think, that's Pokemon. And I think it's quite successful, it's a bit successful because last time I read about them, they made like $700 million in revenue, something like that. So I guess it went well for them at the little franchise of Monster and throwing balls. And another franchise who took advantage of that was also Harry Potter, because of course it makes sense. We're talking about a lot of money. Recently, the new player in town in augmented reality is Minecraft, with this extension called Minecraft Air that actually works in HoloLens and is going to be available in Android and in iOS. And it's definitely very interesting with Minecraft Air as a case because it's actually using Azure Spatial Anchors as a backend, and that's part of the technology that I will talk in more on the end, on the second half of this chat. But if you are not making gaming or a game, or you're not making this huge app for a big company, you maybe just want to have fun. For example, we do with actually we use the Porsche E app, and you say, okay, I'm going to drop a Porsche and see how they see it in more or less the proper scale over the stage in Argentina with a bunch of friends. You took the photo, and well, it just was fun. But more or less, that's the different scenarios where you can do something about augmented reality. But then let's start with augmented reality 101, the basic concepts. Something that's funny with augmented reality is that when you think about it, actually there are only 3 concepts. And all the platforms, Android, iOS, Unity, whatever you can think of, just implement the same 3 concepts. They then add a lot of stuff over that, like lighting, calculation, people occlusion. But the main concepts, the 3 concepts are the same and actually more or less use the same words. The first concept is the session. And the session is your context, the context where your app actually is running. All the elements you create are inside just one session. And later we'll see why this is important. But you can think that is how the app in just given moment is representing the world. And in this case, I'm just putting three axes. The second concept are planes, that actually horizontal planes or vertical planes. That's what the camera picks from the real world during the session, try to identify this surface, this vertical or horizontal surface, and they just call it planes. And then there's your anchors. And your anchors is either a point over a plane or a point that's relative to another anchor. But in the end, there will be an anchor relative to a plane. So that's like a chain of events. Now, how all this came up together? Well, when you try using your app, you're seeing the world through your device, and you tap your screen, for example, to try to place an object. What this is doing is calculating a heat test from what you're seeing on your screen, doing a projection to the plane that's in front of the camera. And that intersection is where an anchor will be created. And this is a point of reference. And what that point of reference, you place at the object. That's the easy way to do augmented reality. Just create a session, start detecting plane, you tap your screen, it will create an anchor, and that anchor, you put a model. Then you can use that anchor as a reference for another one. And that's it. That's more or less the general functionality. You start after that, you start adding all like animation, sound lighting estimation, and sound and stuff. But in a sense, there's all the three concepts that both platforms, specifically Android and Arcade, actually handles. Now let's talk about tools. How do each platform handle that? Well, in Android, the main SDK or the main technology is called AR Core. It's available from Android 7. It's a component installed from the Play Stores, and this is really important. It doesn't come with the operating system. You have to install it by separate. Google Play actually do that. When you try to install your first application that has augmented reality, it checks if the AirCore is installed. If not, it's going to be downloaded. It supports Android, iOS, and Unity. That sounds weird that, okay, it supports iOS, and actually it's true because Unity, when it's targeting iOS, is trying to use AirCore, actually. So they try to support both platforms. The sad news is that AirCore is only available on the latest or the middle to high-end devices from Asus, Google, LG, Motorola, Samsung. I will say Huawei, but as far as I understand, you can buy Huawei at this moment. But actually, that's the devices that support AirCore. And there is this list of these supported devices available on the link that is on the slide that is getting updated more and more. The message here is that when you're trying to do augmented reality with Android, you have to keep in mind that not every device supports augmented reality. So you have to take in consideration that. So you will be a little fragmented, or you will leave in a group of users out of your application. In the other hand, actually, it's not one SDK. The AirCore is the general name from the technology, but actually it's two SDK. One is AirCore, and the other is Inform. Why two SDK? Well, they decided this was a good idea to separate the core functionality from a high-level library. High-level library being Inform. That's the one you actually use because it allows you to create a 3D model, put it somewhere, or add some lighting, or handle animation. AirCore is just handle the image processing. The key part, and when you're working with that, especially when you're working in Xamarin with this, is your Inform version has to be equal to your AirCore version, especially in the NuGet packages. For example, if you will say that this is not the rule, like in general, no. AirCore usually is one or two versions ahead that the Inform packages in NuGet. I'm talking about the NuGet packages compatible with you can install for your Xamarin app. And this is really important because you will use it as your high-level SDK to do most of the job. So when you're adding just reference, just make sure that all the Inform components have the same version, and actually are the same version, the AirCore. For 103D models, it has two formats, SFB, that's for a binary file, and FAA, that's a text file. And this 3D format has all the models and also the textures in just one file. And you need to use the Android Studio plugin for converting this model. This is one of the hardest parts, I got to be honest with you, because I hate Android Studio. I have my personal opinion about Android Studio, but there's not other way. I have to install this plugin. I have to install Android Studio, then install the plugin just to be able to transfer, for example, a 3ds model or FFX model to the proper format. And then is when things get complicated. And with this, I'm going to save you a lot of hours of pain and suffering and tears. Your plugin studio, your Android plugin studio version has to be the same that the same form version of your packages. And that's because Inform is not backward compatible. That means, for example, if I use the plugin version 10 for converting my models and upgrade Inform to version 11, then it will crash. It will load my models. It will say they're incompatible. So I have to go back to the plugin, to the Visual Android Studio, and then go look the exact version, upgrade the plugin studio to version 11, so match the Inform version, and then convert all the models and add it again to my project. This is terrible. You don't know how many hours I spent trying to fix this, try to figure out this. But as I said, AirCore version is one version ahead. So what's actually happened? That AirCore is version 16, Inform is version 14, 15, and the plugin Android in Studio has the same version as AirCore. They need that's version 16. So you have to downgrade the plugin. But as long as you keep everything in the same version, I can assure you, it will work. It will work. And that's the hardest part was working with Android. With iOS, it's different because iOS is called, the technology is called AirKit. It has two SDK, AirKit and ZenKit. I guess Google coupled the names with the scene. And the main difference is that AirKit is updated with the operating system. The first version of AirKit was released with iOS 11, second version with iOS 12, third version with iOS 13. So you get the idea. And that's give you a great advantage because you know that if you're targeting AirKit 2, for example, you know that iOS 12 and all iOS 12 devices has the proper support for augmented reality. That's it. That's simple. So there is no fragmentation, and you can target a bunch of devices with that. With that in mind, it uses its own 3D format. It's called USDC format. You can convert with S-code, and the good news is there's a lot of free converters online for this. So you look into Google, open USDC format converter, and you will see a lot of pages, services, some paid, some free, where you upload your model and all the texture, and it gives you the proper format. So conversion is quite easy, and there's no version compatibility. It just works. Since iOS 12, they have support for shared persistent experience with some limitation. We'll see that in a moment. Has some extra functionality like motion capture. And last year, they were talking about something like people occlusion. And people occlusion is, for example, when you place a model over a table and somebody walks in front of the model disappears because actually the camera detects that the model is behind a person. That's occlusion calling, but detecting a human being. And that is amazing seeing how that works and was available last year. And the big conclusion is this. In terms of augmented reality, Apple is leading the race by a long shot. Google is trying to catch up, actually, to be honest. And is copying some of the things. But who is leading the race in that regard is actually Apple. And that's why you can see that many companies or many applications that has some kind of augmented reality functionality are released for iOS first, because actually it's easier. But how we can do this with Xamarin? We are a Xamarin group, right? Well, we know that we can access both SDK with C#. In Android, I just can add the NuGet packages and try using Google AR.core. And in iOS, use it ARKit. That's simple. I can share my code, my UI. We all know that. But we need a page renderer for each platform because we need to access this functionality per platform inside a view. We need to control the render. That's why we need a page renderer. And we got to keep in mind that through the element binding context, we'll have access to our view model, and we'll see how we can use that. So in general, we know that we have a view model tied to a page. That's simple. We create our page renderer for one view in particular on our Xamarin app, and that page renderer for that particular view will handle all the functionality of all the methods that has to do with augmented reality. But through our binding context, we'll get access to our business logic. So if we are going to make some kind of game, for example, I can just put all my logic in the view model, my high score, all my functionality, the live, my username, all that I need, and I just need all that represent the state of the game can be handled on the view model, and just do the actual rendering or representation on an AR on the page renderer. I just have to write a proper page render for both of those. Because it's a page renderer, that means that I can make also a regular app, for example, like the application from IKEA, that's just a catalog, and then have one particular page or view that has the augmented reality functionality. That's something, for example, you can not do with Unity. Unity, it's the whole app, the game, or the whole app that has augmented reality. So trying to do the app with Unity it will be really hard because you have to simulate the actual app of the application. With Xamarin and this simple approach, you can do any app and just add just another augmented reality functionality, just another feature. So how this is page renderer? Because there are some small details. Okay, you have to add the proper NuGet packages and all the Inform NuGet packages. There are like 12. Set the text compiler to the 8. This is really important. This is default now in Visual Studio 2019, but older projects, sometimes the text compiler is not set or is so. Just make sure it's in the 8. That because otherwise the Inform packages won't compile, won't create your the APK. You have to date your manifest to add, for example, that AR core is required. And what you need is actually an AR fragment. So that's a new type of fragment proper of the SDK that actually is a surface that supports OpenGL rendering. And that with that AR fragment, because everything in Android is a fragment somehow, is that where you can actually initialize AR core. The layout is not complex. It's really, it's just a frame layout. You add your XML resources, add this frame layout, and inside the frame layout that cover all the screen, you add this AR fragment, and it's just a fragment that says android.name equals com.google.com.ar.inform.ux AR fragment. That's it. You only need this layout. Then on your page renderer, you will have actually to set a couple of variables like your fragment, your view, and override 2 methods. The first one is pretty elementary, is the onElement change, because in that method, what you need is actually inflate your layout. So what you're saying, when you go to the page, you are going to take this layout, inflate, and get a reference to the AR fragment. And the AR fragment allows to do, for example, link yourself to the tap airplane event. This is really easy because once you got the air fragment, tapping over a plane, that action or the detecting when the user tap on the screen is just a regular event. So this is just a simple initialization, and mostly all the samples you will see augmented reality has this fragment of code. The other part, the other method, is a bit tricky because nobody actually explained why until you see a black screen. And what's happening is when it's inflating the layout and it's initializing AR core, the actual size of the fragment is not set. You actually have to set up like a new layout and set up the new size. There's a simple method. If you remove these lines and you try, you will see a black screen. Because its size is 0. So nobody actually explained exactly this, but I found that all Microsoft sample, all Xamarin samples has that, and I try, okay, what is doing, and say, okay, it's setting again the height and width of the layout when it's inflating, so it covers the whole screen. So you will see this little override. When you do these 2 things, you will notice something. You will go to your page in your app, it will initialize your page renderer, and then you will see the actual camera. It will ask for your camera permission, but then you will see the camera video frame being rendered on your screen. And that is the signal that AR is properly functioning. If you see a blank screen or the video freezes, then something is wrong, something is happening. But in the moment that you see that the camera is up and running on your session, just like that, you don't have to do anything else, then you see, okay, AR is properly initialized. And that's the step you have to take, for example, with Android. For iOS, it's a lot simpler because ARKit just needs a UI view controller. And the good part is that page renderer on Xamarin, on iOS, inherit from UI view controller. So that means that all page renderers are capable on iOS of running ARKit. Just as simple as that. It's just a regular page renderer, and with it you can add UI functionality, augmented reality functionality. You only need to update your info police because As we all know, in iOS, we need to update the info playlist for almost everything and implement just one delegate. And in two methods, the view did load, you will initialize an object called AR same view that actually is a holder of the session. And then on the view will appear, just try run or start executing your AR session. Initializing AR in iOS is a breeze, actually, to be honest. For example, you have this page render, a sample page render, the same view, and you see that I just inherit from page render and implement one interface. And what I'm doing is creating the same view, and you see there's this session equal, I create a session delegate. It uses a lot of delegate IR kit for almost everything. It can be in separate classes or can be on the same classes if you want. And add this view, and this in the view will appear is where you actually start running your session, and you pass the configuration of how you want this session to behave, what kind of plane detection do you want it to do, what happens with all the existing action. That's, for example, this flag, and you pass all the flags that you need. Again, it's the same behavior. If you go to the iOS, to that in your app, to that point, and you see the actual camera feed being rendered on your screen without issues, then that means that AR is running properly. If the image freezes for some reason, then okay, you have a problem, more or less, probably with some configuration or some parameter that is not setting. But just with those two methods, and you have augmented reality in your app. And this is the way to create the simplest of demo. For example, just like this one. You can download this demo. This was my first AR demo. You see that it's a regular Xamarin app. It has the bar at the bottom. It's okay. And just when you run it, it starts detecting the surface that's represented with these dots on the screen. There was the table, and then it's detect actually the floor. And when you tap the screen, it's just put a model. This is a hello world of augmented reality with Xamarin Form implementing the two renderers I just explained. Because I like to keep this a bit interactive, we can answer a couple of questions. I guess it's a bit boring. Hear me talking for an hour. So, any questions so far?
I wouldn't say this is boring. This is all really cool stuff.
Thank you, Andrew. You're too kind. But as you said, then that means that maybe in a couple of days, all you guys will be putting your hello world in augmented reality. Then.
Yeah, I don't see any questions coming in from the chat. If anyone's got any questions, speak now, or I'm going to quiz you next time. I will actually quiz you guys at some point in the future. I don't know when, but I will.
Okay. Well, if there are any questions, then let's continue. Now, we talk about, this is Hello World. This is your simplest app with augmented reality. But then, what is a persistent experience? And the answer to that is, remember when we talk about the session? I said that session is this context where it's running everything about augmented reality inside your app. But the problem with the session is that when you close your app, your session is destroyed. So everything that you created, all the anchors, all the state, the light, and all the 3D models that you put there are lost. Simple, kaput. So persistent experiences is actually doing something like this. I use my app, I place a 3D model, for example, over a table, and then time passes, maybe hours, maybe days. But when I come back later, probably with the same other device, and I just focus that area, then my 3D model just appear. I don't have to recreate it. I don't have to tap the screen again to put it where I have it. I just look into that, and the model appears. And as I said, could be the same device or could be another device. And this is a small gift courtesy of Microsoft, but it could be your phone, or if you want a HoloLens, if you have one. And that is persistent experience. It's a different session the second time after all the after one time passes, because you're opening your app or opening a different on a different device. But the key is that is we are able to recreate all the elements that was in the original session. So our app can place all the model just in location they were, and replace and restore the state. So that doing that is creating a persistent experience. A non-persistent experience can be, by default, because they are multi-device, multi-user. Because let's say, for example, that I take my device and I focus this table. From one side, I use my iPhone, for example, and I'll place this little fox. Because it's a persistent experience, this somehow can be shared with all devices. So more or less on the same time, if somebody came with an Android device and looks from the other side of the table, they will see the same fox, but from their perspective. So persistent experience is not recognizing just one frame of the camera. It's not recognizing, for example, if I'm focusing my table from the front. It should be able to recognize, for example, if I'm looking the same surface from another or different angle. And when we try to combine two things, looking from different angle, recognizing the same surface, and be able to recreate these 3D models or the location for 3D model and recreate the session, then we can think about something really cool like an augmented reality battle chess, because now we can share our experience with other people on other devices over time. And this is what magic start happening. And this, for example, is what Minecraft Air as a game is doing. Both platforms, AR Core and ARKit, already have certain support for creating this kind of experiences. And for example, in the case of AirCore, Google provides what they call a Cloud Anchor API. This Cloud Anchor API is available since AirCore 1.13, and this is funny because they updated the documentation this year, because last year, I remember correctly, that said 1.12. So it's a bit bizarre because they said last year it was version 12, and this year they say it's version 13. So probably they'll say there's be able on version 14. And the reason of that is because it's still in preview after 1 year and a half. They use the last 30 seconds of the camera to scan the world. So what they do is when I place an object with my camera and I start to using the API, it uses the last 30 seconds of what I focus or scan around this object to create this world map or this idea of the world and store it through the API. And one thing they say that's extremely important is your capture distance. They say some part of the documentation, for example, that if you are 2 feet from your table and you save your model at that distance with the Cloud API or Cloud Anchor API, the API will be able to resolve or find out that model later, more or less the same distance, let's say 2 to 3 feet. If I'm too close or too far, it just won't recognize it. It won't appear. That's it. So they put in bold letters. Distance is important where you are placing your anchor, because that distance is what we use to actually detect the object again. They have some extra privacy requirements, and that's weird coming from Google, but of course, they have some extra privacy requirements. You have to actually disclose that you are using this. They have an extra section for that. But the cloud anchors can only be resolved for 24 hours after they're saved. As I said, it's still in preview. And so the was in preview last year also, and has some weird API quotas. And the problem with this is actually the 24-hour part, because that means if I place this model today, tomorrow will be there, Saturday it won't. So for creating different experiences or making a real case scenario, the Cloud Anchor API doesn't work because let's face it, 24 hours is just too little. And the API quotas is another thing. They have a quota of 300 requests for resolving anchors for app.
300 person using the service at the same time. So it's nice. It's in preview. They said that
actually working to improve this. But as I said, they were working on that, improve this last year. I got that. Andrew, the sounds good?
Your audio is coming in good. We have a question in the chat if we're at a stopping point.
Okay. How important? Okay. How important is hardware when developing mobile apps for a very cheap and refined a decent processor memory per camera? Does it complicate image development? Okay, Lachlan Gordon, as I guess I said your name. I hope I said your name right. Look, regarding Android, you have to look into the list of supported devices. That's the link. There was a couple of slides before. You will see that mostly cheap Android phones that you mentioned, they are not supported. So actually, you will see that mid-range, all Samsung devices, even the cheapest one, support augmented reality. That's for sure. That is the manufacturer that support augmented reality almost on all the devices, even the cheapest one. But other devices, for example, a cheap table from Acer or Asus, probably won't be supported. So the best you can do is actually check the supported list and check the device you are looking for is on that list. And regarding the last question, that complicate development too much? Well, it actually constrains your development because, for example, for experience, one client decided, I want to add this augmented reality in my Android app. And the first thing I have to ask, okay, what version of Android we're talking about? Because you say your app is targeting Android 6, for example, even that is at all, then it's out of the question. It's Android 7 7 and up. And then we have to look at what's the distribution of devices in your country for Android to see more or less what's the target, the amount of users you are considering or you are leaving out. So the question actually comes from that in that report, because you won't be able to support all users or all devices, just a subset of them. And so that's actually, so it's not a development question, it's a reality question of fragmentation with Android. I hope that, I don't know if, I hope that answered your question.
I'm not seeing any other questions in the chat right now. I'll keep monitoring it for you.
Okay, thank you, Andrew. Well, I would say the AR Core service for Cloud Anchor is not actually the best because actually has this weird limitations. ARKit, it's funny because actually it was available since iOS 12, and that's a year and a half, if I remember correctly. Of course, it only supports iOS. And what they do is allow you to capture and save a word map, and I said just word map because that's a term they use on the documentation, locally. It's not an API, it's just something that you say, save word map, and that creates this binary file with a lot of information with all your anchors and save it inside your device. That's saving again. And this word map then can be restored later, and all your anchors and all your elements that you added were there. It's like just a same feature they added to ARKit. And then they allow you to share that word map with other users via peer-to-peer connection. Actually, they detect, the SDK in iOS allow you to detect when another iOS device is nearby. So you can connect peer-to-peer with that device and then share your word map. So that user can restore it and see it from their perspective. And it's pretty cool. That's what the first augmented reality games for iOS were made. I start playing my game, I'm seeing something, then come my friend with the iPad, and through in my app, what it's doing is detecting the other iPad, and then I'm sharing my experience with him via peer-to-peer connection. So all modifications I do to the world map are serialized and shared to the other users. And it's great for certain scenarios. But someone has to be the one sharing. So someone has to start. So if I create I use my iPhone, focus on my table, and place this 3D model on top of that, but I left, if Andrew comes back later with his own iPhone and looks on the table, he won't see anything because I'm not there. I'm not there sharing the world map with him. So that kind of persistence is pretty limited for someone to actually start creating a session. And when that person leaves, unless somebody else is sharing the same workbook with other users, the session gets destroyed. The good news is locally, it doesn't require anything else, an API or connect, and it's totally available. The bad news is that it's pretty limited. But for certain scenarios, like a gaming, a two-person game, works perfectly. As you can see, or you can hear, AirCore and AirKit are way, way too different. And that's a challenge, because if you want to make this amazing augmented reality app with persistent, multi-user, multi-device, the first thing you're going to realize is you can not use AirCore or AirKit, because the experience is just different. So what we can do? That's where Azure Spatial Anchors came in. And this is a service that Microsoft started in preview, if I'm correct, last build, or before a couple of months before last build, they released this huge news about augmented reality and released to the public the Azure Spatial Anchors service. And what they want is allow you to create this, with this resource, allow you to create these experiences where you have multiple devices from Android, iOS, HoloLens, or reality, when they're talking in one moment about that. But all these devices can share the same content. And well, there's a link below if you want to read about it. But basically, a spatial anchor, what is just one SDK, more or less, for Android native, iOS native. That means in Android was Java and iOS Objective-C. Unity is a special library for them. HoloLens is a C++ library, and Xamarin is a C# library. So it's just one SDK for each platform. And one SDK between quotes, because it's not a standard core SDK library that you can put or reference in all your projects. No, it's a SDK for each platform, but it behaves the same. It has the same functionality on all the platforms and the same architecture. So if you know how to use the SDK, for example, on Xamarin, the logic, the classes, the methods, the names, it'll be the same, for example, in Objective-C, in Java, or in C++. The only difference is it will be use the proper objects for that language. In C++, is a lot of pointers that you don't have in C#. But the general architecture, how the service works, is exactly the same. So they say that's just one SDK. And what they want to do is to leverage AirKit and AirCore capabilities. That means they will let the actual render or AR functionality be done on the proper SDK, AirKit or AirCore, according to the platform. They only will handle how to solve an anchor over a spatial anchor, as they call it, but actually it's a permanent anchor. So creating and then locate that anchor on a later session. But as I said, the actual rendering, the actual how do you represent that anchor on AR, that's a problem you have to solve on ARKit or ARCore. And with that, they allow you to create this persistent content and enable multi-user experiences. For example, the Minecraft Earth on the top picture, or below, that was a weird picture they put on the Microsoft page, where you see, for example, you can mix IoT with HoloLens and start creating this with Blade Runner style UI where everything is floating around with augmented reality. So, but it's with the service. How this works, how this is happening. Well, when you place your object over a surface, you have to start scanning around this object. And what they do with the camera is they test a series of dots. These dots are always being detected because it's how augmented reality works. But then they allow to collect all those dots, or this, the world map is this collection of dots that represent all the different surfaces the camera is picking, and then allow you to save it to the cloud through the service. Then later, when you are trying to locate or restore, what it's doing is this, okay, I'm looking to my camera, I'm seeing the world, I'm picking these dots, this cloud of dots that represent my different surface, and it start comparing them with what's on the cloud. Even it could be a different angle, but there is a certain degree of comparison. And when they decide, oh, look, this image or this point of view that you're picking in your camera, this collection of dots matches this one that was previously saved. And for example, and that means that in this point, there's an anchor. And then you can recreate the anchor and put your 3D model and then restore your session. That's how it works. And don't worry, because actually I'll be explaining more about the process in a bit. Using the service is really, really easy, like most of the things with Azure. You just go to Azure, you need to buy a subscription, and just create this new resource called a spatial anchor account. As I said, it was in preview at this moment. You will need actually two things. The account ID, that's a value you see on the review, you have to copy that, and then it will give you a private key. That's it. With those two elements, you can initialize this service on your app. And how this works now from a point of view of a diagram. This makes everything clear. I have my Android iOS application that's using ARKit. For example, my Hello World app that I just showed you a couple of minutes ago. When I create my session, then I'm going to pass this session to another object. That's a Cloud Spatial Anchor session. That's part of the Azure Spatial Anchor SDK. I just pass, this is my session. Then for each frame of video, because the both kits allow you to get each frame of the camera, I'm going to call a method that says process frame. I just pass the frame to them. That's it. Now, when I create an anchor, let's see, I'm start focusing my camera and I focus horizontal surface, I place an object, it creates an anchor. My sessions get updated, and then it would call a method called session updated. And that method is going to start actually scanning. And this is the difference with the Google API. It's not time-based. It actually, the SDK tells me when it actually has enough information to save the anchor. The Google API, if you recall, uses the last 30 seconds. In this case, it doesn't. It's an event that it keeps running constantly. That's the session updated. That is saving, and it's just this flag. They said I have enough info right now to save the anchor, and then you call the method create anchor async. This is really interesting because I found out for testing, for example, that in some cases have to scan really slowly around my object to actually create have enough information to create this anchor in the cloud. And sometimes, depending on the object or the distance I have to the object, is just a quick scan, and then say, okay, this is enough for me. So actually, it's not that fixed with times. It actually is considered your real scenario. And that's it. Now you have your anchor on the cloud. Now, when you want to look for an anchor, or you want to look for something, you have to specify what you're looking for. You will get an idea and say, I look for this something or these IDs or this anchor in this area. And actually, the video is saving the camera, is being saved. In this element, while it's processing the frame, if it found an anchor, it writes an event that says anchor found, and the anchor found is done back to your app. So now you have this information. Okay, this service found this anchor in this location. It's a world coordinate. It's a location in world coordinates. So you just can use that location, that anchor, to put a 3D model on that. And that's how it will basically appear. If we go to our previous demo, or hello world and augmented reality, that was a diagram. I have my view model, my page render, augmented reality. The big question, okay, that sounds good, but now how I plug in the Azure Spatial Anchor functionality with the demo that I have? Do I have to rewrite everything? Do I have to make some radical change in my design? And the good news is that you don't, because you can do something really, really simple. First, you have to create an interface. For example, I call it Spatial Anchor Service. That's my interface. But that interface, what it does, is implement a set of methods for Android and iOS. And that's because, as remember, I don't have a core SDK or net standard SDK. I have an SDK for each platform. So I'm going to create my interface and do some implementations on both platforms. Then what I can do is pass by dependency injection my service to the view model. And that's the trick, because if you remember correctly, our page renderer has access by the binding context to our view model. And through the view model, now we have access to the interface of our service, actually to the proper implementation in our platform to the Spatial Anchor Service SDK. And with that, I can actually pass the frame, create the session, and hook up to the events, for example, when an anchor is located, and then thank you, Andrew. And then I have this all this information on how I can recreate the object in my platform. I repeat, remember, the Spatial Anchor Service, what it does is only say to you, allow to save an anchor, and then look for that anchor, so you can restore it. How you render that anchor has to be on your AR functionality, in that case, on your page renderer. And you'll see that that interface for Spatial Anchor Service is really, really simple. It's kind of a joke, actually, because this is only you need. You need actually to set the mode. I'm actually adding anchors and creating something while looking for something, get your status, and the event handler, because you need somehow interact with the SDK, and the obvious method. I have start a session, start located answer, place a model, you stop your session, or process frame. And you see that I'm passing object as a parameter. And I know that's not too elegant, but the reason of that is that each SDK use the object, the type of object of the platform. For example, on Android, for creating the object for transform, matrix transform, is different than the object for iOS. So the way to create an interface, or you can do some independence injection, is, well, you declare object. It's one way to do it, and you do on your platform, you do some casting. It's not really elegant. Maybe it can be done better, but allow you to solve the problem really easy, especially how you can plug the Spatial Anchor Service in your application without touching too much. So you can make the same application that we have, the same demo, and now expand it with persistent functionality. And the big part is, okay, that's good. Now we have the Spatial Anchor, but what about multi-user? How we handle that? Well, If I create an anchor for my device, I'm just calling something to my service. The service is going to return to me an anchor ID. And that ID is nothing more than a string. A string that is a hash value that represents all these dots of clouds that were saving on the service when I was scanning the room. And that ID is what I use to later look for a model. So what I need to do is actually share that ID with other devices. And for that, the easiest solution is with an API. So I can create this REST API with Azure Function, ASP.NET, whatever you want, that allows you to save that ID on a database. It's just a string. You can save it in an Azure Storage Table if you like, or SQL or Cosmos DB. It's just a string. Later, a second device, what it needs to do is retrieve those IDs from their API so they can start looking for the same anchors on their session and call the service to search. And when they found it, they do the recreate on their side the exact same session. One question that somebody asked me is, okay, now why an API? Why I need these third elements? It's a bit bizarre. Why Azure Spatial Anchors doesn't provide an API for saving your objects? And after some analysis, I think that the answer is freedom. Because in a real context, for example, for a game or an app, you won't be saving just the ID. You will be saving some state information about that. For example, it's not just that there is, oh, this is model, but for example, if a game, what's the state, what's the 3D model, what's the life, what's the state inside the game, if what's a sofa, for example, in application, what's the color, what's the 3D model I should use for that color. So probably in your real context for your application, you will save it a lot more than just the ID. So it's better if you have that flexibility to create your own API with your own 3D models. And the only things that you need is add a new field to save the anchor ID. And why the anchor's ID? Because I need to look for certain things. For example, if I create special anchors around my city, it won't be realistic, for example, for my app to look around for the presence of a dozen or 1,000 anchors on camera when only a dozen of them, maybe 3 or 4 or 5, are actually near me. So what they suggest in the documentation is, okay, they do something simple. You have all your IDs, but somehow you have to be able to detect or figure out what actually are the anchors ID that are of interest for you in that moment, the ones that are near you. And then you can start looking for them. And that allows you to get faster results. So you will see that, okay, this anchor was near in my location. For example, that's the one I'm trying to look for. So that's the way, that's the reason why you need an API. You will save extra information. For example, hail location, latitude, longitude in your app. And it's not that bad because it's not a complex object. After all, it's just a string. When you do all that, you will come with something just like this. On the right side and left side, I was creating an object, and I just placed my object. It's exactly the same demo that before, but then I start moving around. I start in this moment and scanning. I just picking all these dots of clouds around the object until it says it's enough. And in one point, it will give me that signal that the anchor and the object, it has enough information and was saved successfully on the cloud. Now, on the other side, I can look for objects, and I can look for anchors. And one thing you will notice that it's not picking the dots. Objects just appear, just like that. And I created these to actually work like 3 or 4. I created down a road to the stage. This was during an event. And I created one day, and the next day I just started working around. That's when I recorded the video. I was looking to the floor, and the model just appeared. And that's the real magic of a spatial anchor. You don't see you're doing something else or detecting something. They just show up, and it's really, really fast. Now, of course, for using this service, you have to take some consideration. You have to provide a good user experience for creating anchors, because you see, I have to scan around, and part of the user experience that you have to consider that is that use location with stable visual features. For example, an empty room with white walls, no furniture, is very poor for creating an anchor, because there is no visual element to actually later look for an anchor. And please don't create anchor on highly reflective surfaces. That's a general problem, not for SDK. That's a general problem with augmented reality. If you try any augmented reality application, you will see that glass surface, highly reflective surface, you can actually place a model, and this because it doesn't detect the plane for actually at something. And if there are patterns that repeat, like a carpet, it's really hard to actually later locate an anchor, because it won't be able to decide exactly which part of the carpet. The good news about Microsoft is that there's a great guideline, that's the link, about how you can create good anchors that you can detect on several lighting conditions from several angles, or the kind of consideration regarding the scenario you want to model. For example, if I want to model a set of waypoints around a doorway, there are recommendations where do I have to put my camera to create the anchors. For example, if I can some arrows on a shopping mall. But if I want to just put the model inside a room, then where I should start scanning the room, or how should I start scanning in order to detect the same element regardless of my point of view. But if a user has to do this, then you have to provide the proper UX so they can understand what they have to do. This service in its current state is now free. Last year was in preview, now is out of preview, is completely free, general availability. Paid tiers will be available starting in, I guess, in a couple of months. And it's used in Minecraft Air. I don't know if they use Minecraft Air as a test case for the service, or created a service for Minecraft Air, because they two appear at the same moment. But in one of the sessions, not this video, the last one, they mentioned that, okay, we're using this with Minecraft Earth. It has some accuracy issues, but it's getting better. When they say accuracy, it means that sometimes when it detects the model again, the second time, it's not exactly in the same place. It's like an inch or two for one side, or etc. That happens. But it's getting a lot better, and especially a lot faster. The last time I do a test, it was almost immediate. I just focus the phone, and the 3D model just, and it's great. And regarding the cost, they haven't announced any price, but as everything in Azure now, probably with some serverless or free tier that you can use. And the big question is, okay, where we go from here? What's next? Well, the new service that Microsoft announced last year was remote rendering. That service was first announced as a private beta, or private alpha, to be honest, and now it's in public preview, but it only limited to HoloLens at this moment. And the idea of remote rendering is this. Right now, all the processing power is on my device for rendering a 3D model. And you will see that most models are quite simple, especially in terms of lighting and polygon count. And that's because even though phones are really powerful, but still they cannot handle thousands of polygons. So highly detailed model, like a building, for example, for an architecture scenario, is not completely possible right now. So the idea of remote rendering is that make that functionality, the render functionality, on the cloud, and then stream what the user should be seeing, and mix that with the camera. And it's kind of, this is really, really cool actually to do this, because we are talking that we are streaming the 3D model being rendered and then showing on several devices on the same time with different perspectives. Right now it's in HoloLens. There's a couple of video, but remember, a spatial anchor service started with HoloLens 2, and then they are the mobile devices. So yes, probably a mobile SDK for Android or iOS and Xamarin will be available down the road. But this will allow us to actually do high fidelity 3D models in augmented reality. And we solve also one problem. Remember what I spoke about, the 3D formats, that we have a format for Android and format for iOS. And I didn't tell you, but if you are doing an app for both platforms, you have to start converting your 3D models to both platforms and deal with the scale that's different. With this, that problem will be a thing of the past, because you only need one model and be on the cloud. So I'm really excited to see how this start working, and I guess that's probably next year. But in that regard, it will be amazing. This kind of experience we'll be able to create, especially because this is on top of actually the spatial anchor service. So that's why they need their first service first up and running, and then working on that one. And with this, my friend, this is, I finish my talk about persistent experiences. I'll let you, here are the links for my GitHub account where you have the AR demo and the spatial anchors demo, and you can reach me on LinkedIn, you can reach me on Twitter if you want to talk about it. As I said, I don't like, and not to open Visual Studio and writing too much code. I like to talk about the hows and whys of DCK, or the different likes and difficulties I have with the technology. So you can actually, I hope the idea is to help you if you decide, for example, do your AR or implement this in one your project. I hope you like it. Well, if you have any questions, let's hear it.
Mm-hmm. Very good. Thanks for the presentation. This was really great content. You don't need a code demo to have really great content, and it's just very well done. If anyone's got questions, feel free to open a mic or drop a line in the chat.
Thank you, Lester.
Amazing talk from Lester. So who can I nominate to do the follow-up talk for I haven't touched AR, but this is my getting started guide?
But usually when there's no question, there are two options: or everything went great, or nobody understand. Nobody understand anything. So everyone is sleeping, but that's okay. That's okay. I like
there's a lot of content here. I mean, I could not go tomorrow and implement this solution. I would come back to the recording and really focus listening on certain parts. But you give me a really good overview of if I was to go and, let's say, talk to some stakeholders at my company about why we should use AR, and if I need to do a talk on a technical level of here are the problems we're going to run into by using, you know, ARKit and AR Core, and why we would need to use Azure. You know, there's you've given me a lot to think about on AR implementations.
Well, thank you. That's the whole point. That's the idea. As I said, talk about the hows and the whys of things. So that's the objective.
And that's the mark of a good talk. I mean, people start walking away with, oh, how those little bits. All right. Well, if there's no questions, I'm gonna take over presenter for a second, and we'll head into group time. Let me make myself presenter and share the PowerPoint slide deck. All right. Update. All right. So we're going to stop the recording and the live stream, and we're going to break up into group time. We don't have a date announced for the next meeting, but keep an eye out on Twitter. We're probably going to do it towards the end of June. and I'll announce it once I have a speaker lined up and confirmed. But until next time, thanks everyone for coming, and Burgard, thanks for doing the presentation. It was a very good presentation.
Thank you, Andrew.